Hi everyone. Uh, the presentation topic is optimizing urban microclimate and energy consumption in residential growth areas in Melbourne. This is a part of my PhD project, supervised by Professor Priya and Associate Professor Maila in the PCPM. So the main idea of the research is that can we consider both indoors and outdoors together without neglecting the effects that we change in outdoors on indoors or the other way around. So in earlier stages of the research, previous research, the buildings considered as standalone structures detached from their dwellings. For the simulations, they use climate files from airports, which is completely different from microclimate data around the buildings. With more improvements, we can have some elements from the environment, for example, shading from the surrounding buildings. And now we can think of improving simultaneously both indoors and outdoors at a bigger scale. At the same time, we know that there is a huge demand for new houses in Melbourne, focused on the western part of the Greater Melbourne, and there are major changes in the market. We know that the smaller lots are becoming more and more popular because of the social and economic factors, but we don't know at the larger scale these changes, how can they affect the outdoor thermal conditions and consequently the indoors. So this research will try to develop a framework which simultaneously assess the outdoors and indoors, and also it considers different time frames, winter conditions, summer conditions, and also extreme weather conditions such as heat waves. Another major problem in the literature can be lack of enough consideration of greenery and water features in simultaneous improvement of outdoors and indoors. And also, this research will use measures and scenarios informed by social, economic, and regulatory frameworks and constraints and preferences. So this presentation is covering this part. This part is qualitative data collection and assessment, which is mainly done to capture the social, economic, and regulations from stakeholders through interviews. These can affect the urban configurations, and after that, a simultaneous assessment and simulation of urban microclimate and energy consumption will be conducted through different time frames, and after that, improvement stages will be done. So we know that there are some problems particularly in the western and southern eastern part of the Greater Melbourne with the urban heat problems with higher land surface temperature and air temperatures. So a site in the western part of the city is selected, and this is a summary of my computer modeling for the outdoors. The study uses NVMed, and for the energy consumption, Energy Plus, which will be coupled to each other. So from the interview insights, which is not covered in the slides, but there are different scenarios for the minimum and maximum possibilities that the interviewees mentioned that can be practically employed in the in the new developments in the growth areas. So we have different scenarios for lots, for the distributed greenery, for the materials, and for incorporating park blue and green spaces. So the major problem for microclimate modeling when you use a CFD model is that it is too slow to run, and it needs a high spec computers and a lot of simulation running simultaneously. So around 400 hours were spent on high spec computers and AWS, and we needed to do it in a short time frame because of my PhD milestones, and also high spec CPU were required for the microclimate modeling and simulation. So each simulation also create a large output files, around 20 gigabytes each runs. This is separated from the testing and testing to solving the crashes because of the CFD modeling and changing in the wind and all of that. So thanks to RACE, we could use a lot of those resources. So this is a part of the outputs. This large scale and this large number of scenarios couldn't be done unless you have access to some really good computer resources. So this is the air temperature when different interventions in different time frames are applied, and you can compare effects of different parameters. Similar things can be done for other factors, for example, outdoor thermal comfort or any environmental parameter, and be visualized into the graphs to measure the effects of different parameters. So the next step after microclimate modeling will be energy use simulation, which will be smoother because it doesn't need such a high computer resources, and then a statistical analysis for the scenarios and another stages of simulations. At the same time, validation should be done through the field measurement in the real site. So the impacts are the insights into pattern of changes in the outdoors and indoors in the growth areas when different parameters are changing, and also measuring and including the effects of greenery and water alongside the typological and geometrical parameters. The suggestions of this study will be focused on detached houses because we know that in the literature, the previous study mainly focused on different typologies, for example, comparing houses with apartments or high-rise building. But this study will suggest some measures, particularly for detached houses, which is the major part of our developments. And also, thanks to the qualitative data collection and analysis, these measures will be practical because these are informed by consultations with urban planners, designers, city councils, and also developers and volume builders. And at the end, a holistic insight into different thermal conditions in different time frames will be achieved. Thank you.